Welcome to Real Physics. There are actually two ways you can watch this video. The first one is about the fundamental questions of physics. I really like that is Mach's principle, variable speed of light, and the computation of the gravitational constant. And it's a very exciting field, but I apologize if you watch it this way. It's going to be a little bit technical. Maybe you need to study some papers before you can really enter the discussion here. But I would also encourage you to watch this from a meta level, because the AI revolution, I think, is going to change physics profoundly, the way we humans do physics in the future. And again, I'm absolutely stunned by DeepSeek's capabilities in here, which I think is the leader for me. It's the leading model in theoretical physics. So if you're not going into the details, but if you just focus on how he responds and how he's doing all these calculations, it's just mind-blowing. By the way, I'm doing the best to give you a non-BS perspective on fundamental physics as it was practiced 100 years ago versus what they tell you today is fundamental physics. So if you enjoyed the video, don't forget to leave me a like and subscription. Now let's just get right into the matter. And I said just read the formula in that abstract. I'm talking about a paper I have mentioned several times by Cook in 1976. And it's also mentioned in this video and that video, of course. I'm talking all the time about Mach's principle in calculating G. The idea is that gravity depends in a not machine, that was a typo, but he understood it in a Machian way, according to Mach's principle. From all other masses in the universe, Newton's big G should turn out to be determined by the mass distribution in the universe. I want to link this to variable speed of light, the acceleration being of the form a gradient of the square of the speed of light. Can you suggest a formula? That's also funny how he thinks about and comes up with the first suggestions. I don't go into the detail here because it would take too long, but I leave you the link here and you can study it with all the time you need. Yeah, but I mean, he perfectly understands what I wanted to say. He starts from the Sharma-Dicke formulation, and he also implements the idea I was suggesting. So after a while, he came up with that proposal, and even I think if the calculations were correct, I didn't really like, because there was still G appearing in the formula. So I said, okay, but I want G to be explained, akin to Dennis Sharma's 1953 suggestion, so G shouldn't appear in the final expression. And then he thinks about 2.5 minutes. It's also very funny to follow up on all these. These are all just thoughts he internally processes and rethinks and questions, and I really like that approach because it's so scientific. Yeah? You know, you start with brainstorming all the formulae and you work out the consequences, and yeah, sometimes you meet a dead end. And then eventually, after a lot of thinking, he comes up with another proposal here. Let's see. After that long thinking, he has perfectly understood what I mean. He evidently has also read the paper by Dennis Sharma, and he comes up with that formula, which is okay, but what I miss here is a really clear distinction between what he calls local masses and distant masses, because at the very end, where you draw the boundary, which is not artificial. So I said, okay, but how exactly is the numerator distinguished from the denominator? How to define what is local? And then another 3-minute pondering. It's really funny. And I think it's also worth analyzing and studying that in detail, maybe for the computer folks. But yeah, what should I say? I mean, I'm a human. For me, all these calculations are very tedious, and I do make stupid errors. So what I see here is just a fantastic possibility of collaboration. And this is still thinking. Yeah, now his answer, pretty reasonable again. He's very close to that original approach by Dennis Sharma. And yeah, this would be his final answer if you want. And the important thing is not if this is the final answer or the revolutionary new form of gravity, but he very accurately addressed my concern about his formal solution, and it's okay. If you want, he resolved the problem here. Now I saw that this was quite similar to a version we had worked out together with my coworker a couple of years ago. So I said, okay, the denominator here could be seen as some reference speed of light squared. And wouldn't be even better if in his formula we exchanged the numerator and the denominator. In that case, you would have a concrete reference to the local observable speed of light, instead of postulating some speed of light very distant from all other masses. Yeah, and again, he perfectly understood what I was saying, and he figured out the technical consequence here. I think it's really great, because he understood that in that case, you have to switch the sign. However, if we instead define minus the gradient of the speed of light, then you can do it that way. And yeah, in this case, he has just been such a great assistant. I don't want to go into the argument of whether this is real creativity or not, or whether he himself would have come with such an idea. And of course, I don't claim this is the final solution to a problem of gravity. We still have to check and to look and to see if it matches the observation, and presumably it will turn out wrong. But that's not the question. I think the question is that this opens an entirely new way of doing theoretical physics, because, I mean, I purposefully phrased that in a very sloppy way, and he perfectly understood and he perfectly implemented what I had proposed, and at the same time he spotted the inconsistencies and the fixes that were needed. So I think at the moment it's just a beautiful complementary brain, if you want, that works, of course, very formally and accurately, and maybe, well, one day AI will replace us at all, but I think this is really good news for physics. By the way, there is a book now on pre-order about physics and AI, but it's the German version. I put it in the description, and of course there will be also an English version available quite soon. Thanks for watching, thanks for commenting, thanks for liking, and thanks for subscribing.